Hey guys, I'm out today at a meeting, so I'm going to make you guys a video to get you started onto this task, which builds on the last task. Turn to experiment 1. Up above in the instructions, all they do is they talk about two lines on a coordinate plane, like this one and this one, and how if they are perpendicular, we know that they form 90-degree angles because this one is vertical and this one's horizontal. That's really easy to see. But when you have a line that is not horizontal and vertical, which most lines aren't, we talked about last week how to spot the line that is perpendicular to it by looking at the two slopes. So I'm just going to jump right into experiment 1 here. It says consider the points 2, 3, which is this one, and 4, 7, and the line AB between them. What is the slope of the line segment? So we can see real quick that it is 1, 2, and 1 over. So this gives us m is equal to 2, or you could write 2 over 1. So go ahead and fill that into your module. Next one says locate a third point, C, X, Y, on the coordinate grid so that A, B, and C form vertices of a right triangle, with AB as the hypotenuse. So I'm going to go ahead and mark that here. And let's go ahead and fill in that right triangle. And you can see I also could have placed it up here, and that would have formed kind of the opposite right triangle, opposite but congruent right triangle. And then C is the point. Let's just jot that down. 1, 2, 3, 4, 3. So 4, comma, 3. Okay, I'm going to leave this triangle here and put the other questions that we need to answer underneath the camera if I can fit everything. I think I barely can. Good. So it says explain how you know that the triangle you formed contains a right angle. Well, the triangle that we formed, you could just write it has, or it is formed by a vertical, this line, and horizontal lines, or it is formed by vertical and horizontal lines. 4, rotate the triangle 90 degrees about the vertex point 2, 3. Explain how you know that you've rotated the triangle 90 degrees. Okay, this is the part where it gets a little tricky. So the point 2, 3 is right here, so go ahead and put a heavy dot on it. Now, it doesn't say whether or not you should rotate it clockwise or counterclockwise. So let's just go with clockwise for today. So this triangle is going to move in the clockwise direction 90 degrees. So we have this point C right here, and we need to just picture this coming down here. This is a 90-degree angle. C is going to move to here. A is the rotation point, so it's not going to move at all. It's just going to pivot around A, and you can see this coming down to here. And then you can see that the hypotenuse would come all the way down to here, and it must be a distance of 4. So 1, 2, 3, 4. And here is the triangle rotated 90 degrees clockwise. And this is A prime, this is C prime, and this is B prime. So we explain how you know you've rotated the triangle 90 degrees. Well, I'm going to go ahead and answer that in number 5. So it says compare the slopes of the hypotenuse of the rotated right triangle with the slope of the hypotenuse of the pre-image. What do you notice? So the hypotenuse, remember the longest side of the triangle, the slope of the pre-image, which is this one, was 2. So pre-image, m is 2. And on the image, let's check it out. So here's the hypotenuse, and it goes to here, and it looks like the slope is down 1 over 2, down 1 over 2. Down 1 over 2 is a slope of negative 1 over 2. So I know that that 2 and negative 1/2 form perpendicular lines. And we learned about this relationship last week. So as you move forward, they're not all going to be as easy as 2 and -2. They might be like 3/4 and -4/3 as an example, or -6 and 1/6. But you guys get the idea. So take what you know from problem number 1 and continue it with these lines as well. Thank you.